As you see the program.
Yes.
Yeah, we can see it's running.
Okay. Because I have the computer here, and then I didn't see it on mine, so I just wonder if you guys see it.
So far, it's passing.
Okay. So I will run a couple tests, D-Lab 7 and then D-Lab 6, D-Lab 5. I'm not running all of them, but if you already upload the 7, 6 and all of your tests, it's upload. If I haven't run it or I already run it or you don't see I run it, that means it's already passed, okay? If you upload. If I will bring up as anyone is a test, it's a fail. But I run it just for a sample, it's 2 or 3, depend on how much time we have here. Okay.
You can try to pick which one technique fail, try to run. So we try to help them to fix that problem.
When I got this test upload, I check it, and then if it fail and which one fail, I fix it. Just simple, I fix it, and then I will bring it up. Okay. But if they all fail, I just they all pass, so I just run as a sample.
Start without debugging.
Yeah, without debugging, just run the test, okay? If something is it's typical, and I think it may be it's for everybody need to know, and then I bring it up when I fix it. And now I'm going to run lab number 4. Let's see, lab number 4. I have a one at Mr. Marcelo.
Mr. Pham.
Okay, Marcelo program number
Yeah,
4. You
Mr. Pham, going back
yes.
now, you on your page for number 7. For my
Your lab, I make a change on your lab, okay, to make sure it pass, it
Right.
fail.
So what I'd like to know is what's it that you change?
So let me see. I have to bring up.
Do you have the
Let's see.
original one? Maybe you can run that and see where it failed.
that next time, Mr. Pham, don't try to fix it. Fail it, put it fail, and
Right.
run so we can see it.
Right. Otherwise, I don't know
Okay.
where I made the mistake.
Let me see. I still have your original here. Okay, make sure it's number 7. I think I have your original here. Okay, let's put your original in, and then I think this is the one it's original, but we'll see.
Okay, next time, make sure don't try to fix anything. Fail, just put it fail. And when we run the one it failed, not run the one it passed.
Okay. That is your original, Marcella. Oh, you look.
Yeah.
Okay, you don't have the program name and display the program name, and this is test number 1. The test number 1 if
so that's where the
this
mistake.
is test number 1 fell. Okay, now I show it's why it fell. Because you are missing the end clock after write port A. Right here. See it? You write port A, and then you take a test evaluation right away without a clock. So that's why it's a test fail.
Oh, it need a clock when it, okay.
Yes, and then now the test number 2 is same thing.
Okay.
Okay.
Mr.
So if you can go back to rework on it and upload again, but I have I already fixed that, and now you know what's wrong with it.
Right,
Okay.
right. Yeah.
So and then it's your test number 20. That's a CR, and then the last test number 37 is a BR also failed. Make sure you check on the masking data, and then it just review it again and upload again with the update.
Okay.
Then I will check it for you.
So
okay.
for every step, I suppose to have the clock then?
That's right. You need a clock.
Okay. All right. Thank you.
You're welcome.
Marcelo
and now
here.
we go back to see it's test number 4.
Mr. Pham, did you call me?
I'm here.
Marcelo here. Did you call me?
No, he called by mistake.
Okay, okay.
And Marcelo, here is your test number 3. Okay.
Okay, I'm here.
Yes, I show you this is what your test number 3. The lab 3 look like. You see it right here. You have only 3 tests. You need to upload complete the test. Okay.
Huh? I uploaded the complete code.
Really? As when I run it, pass only 3 tests, and then I look again, but I didn't see any.
Let me check. Let me check.
Okay, so go ahead, check it out.
Visual Studio.
And then also this one is the simple. I fixed it. It's the first line, very first line. You need to comment it out.
What do you have to comment?
The first line here. Okay, the first line of the program is say copy this program to your project. That is a comment. So you have to put a double slash in there to make sure. If not, and then you see I just review build it, and then we got an error.
Yep.
Now I have review it. Okay, that is the first line of your program. Need to comment that one out. So now it's ready, and I will run the lab number 4. Oh, this is the lab number 3. I don't have okay here the number 3.
Okay, for the number 3, I upload one with 13 tests.
Really? Okay,
yes, sir.
Let's double check.
I can send you. I can show you if you want now.
I just check on the web here and see.
Okay. Okay.
If you have that, it's in there.
Okay. Okay. Okay.
Okay, here is one. The lab number 3. This is the one I got it from. Only 3 tests. Okay, the lab 3, spring 2021. I don't know where you got it. The one with the 13. Okay.
Okay. I'm going to upload it again.
Okay, now I run that, and we will see that it's only 3 tests. Oh, this is the D lab number. Let me check to see D lab number 3.
And also I'm checking the
No, this one D lab number 4.
But maybe that the number 4 is the from the previous quarter, because I have not uploaded yet the number 4. Actually, I'm confused now.
That is the lab number 4. I'm sorry, D lab 3 you pass. D lab number 4 only 3 tests. Okay.
Okay, I'm going to upload the number 3.
So you go ahead,
right
upload
now.
again, and then I will check it.
Okay.
Later. Okay, and now I have another couple. It's a test on number 4. It's Mr. Rubio. You there? Because I didn't see much of your D-Lab upload, so I want to show you what you get here, Mr. Jose, Rubio, Jose.
That one got Mr. Pham's name up top.
Oh yeah, I see his name here, Jose Rubio. Okay, and here's your test number 4.
Le pregunto a la persona encargada que dónde estaba el fundamento de ese voto, porque en realidad me dicen que hay un encargado con ese taller de encargado.
Mr. Pham, turn on your microphone.
I don't know if he heard you, Mr. Pham.
He not turn on his microphone.
You might have to call him and tell him to cut it on.
Okay.
Rồi mà tại sao giờ tôi kiếm cái website đó nó lại không ngồi?
Turn on your microphone.
Okay, I see, I know.
That one passed. Hey, Mr. Pham, can you hear us? The other Mr. Pham?
Yeah,
No, the one that's
I
running the.
already told him.
Can he hear you?
Okay,
Oh, there
now
you go.
you hear it, right?
Yeah, go ahead.
Okay, so Rubio, Mr. Rubio, your test, D lab 1, 2, 3, 4 on pass. You need to work on 5, 6, and 7. And now let's see if I have any more lab on.
Okay. From
Is
now
that
on.
all?
Okay, from now on, okay?
Yeah.
If you check their software, if they part, put it part, don't worry about that. Only we run any program is not part. Don't try to touch into their software. We don't care. We just want to run. If they fail, and we find out what's wrong with the problem and let them know how to fix it. Don't run any program and you already top.
Okay, so from now on, I will run, and if already test already passed, I will let you guys know that you pass with the Excel chart. Okay, and then if it fail, I run it. I show you it fail, and then I show maybe it show you how to fix it, and then you have to upload again.
Okay. Yeah, Mr. Hanfam, I upload the number 3 just in case.
Okay, you upload number 3.
The C++.
Oh no, number 3 is already part. Number 4 is the one you only to have a 3 test.
Okay, okay.
Number 4. Okay, so upload it again and then I will check it next time.
Okay. Thank you.
You're welcome. Any question?
Thanks, Mr. Pham. Thanks a lot.
Okay, thank
Mr.
you
Pham,
guys.
Thank
Mr.
you.
Pham, can you
I
show?
stop share now.
Can you share a sheet where show us what we passed and what we failed? The table.
Mr. Pham.
Mr. You look, you just say something?
Now,
Yes, I said.
Yeah.
they want to display the status of the student for the D-Lab who passed, who failed. That's what he wanted.
So you going to show it? I go to show it.
You go ahead and show it.
Mr. Pham?
Yeah, you go ahead and show it.
Okay, so I'm going to show that one now. Huh?
You go and show it.
Okay, the first one that I go to share my screen first. Okay, and here is the charts. What I have for you guys on the D-Lab number D-Lab Tech 2. Okay. Now you see it right here, right? And this is all, it's D-Lab 1, 2, 3, 4, 5, 6, and 7. Mr. Jeffy Maddy, you got the 7 of them. Cooley Brian got only one, D-Lab number 1. You need to work more, okay? And do E10 and do Suyana. I think that Suyana is a pass more test. Let me check in here. Let's see. Suyana, you have a number 5 pass already, okay? And Lu Yuk, you have a 6 lab pass. And I think it's a 7. We just run it today, right?
Yes.
And then those tests, it failed, but I fixed it. But you need to
I'll change
upload again, so okay, you can get the credit for that. I already saw it, why it fell. Okay. And now Mr. Nicholas Worcester, you got 7 of them pass. Very good work. And you already see this one is what you see on your monitor, on your screen is if you read by your name, we are going to like alphabetic. So you look into there, check your name, and you see how many of them is part. If you like Mr. Oscar here, if you upload 2 and you have that 2 pass. If you upload more, I will check for more. Okay. Yes.
Mr. Pham, Marcelo here. I cannot see my name on the.
Okay, here your name up here. Your name is up to here, my Mr. Marcelo. So the number 3 pass and number 4 is 3 test pass. Okay.
Thank you.
And Butam Kumi.
I'm here.
Yeah, you have a 5.
Number 6 coming up.
D-Lab pass.
Okay, Kumi,
Yeah.
you superstar, Kumi.
Thank you.
And now it's Bonding Adam. You have a 7.
Adam, a
D-Lab pass.
superstar.
And Smith, Mr. Smith, you
Yes,
got
sir.
a pass all 7.
Oh
Good
my
work.
God,
Okay.
superstar.
So you guys keep waiting for the D-Lab number 8 and more later. Okay.
All right.
But it's a very good work. If you pass all of the 7, that means you complete your job up to this time. Any question about this child here? If I miss anybody,
Thank you, Mr. Pham.
okay. So
And Michael, you Luke,
next
didn't you have
time,
number 7?
huh?
Michael, you Luke, didn't he have number? Didn't he pass 7?
So I had mistake and Mr. Pham did the correction,
Oh,
but
So
I will
like
correct
it's a
it
next
and
week.
submit it.
What I'm going to show you should be the chart like this, and then which one I have a file, I will mark it file, and then I run that, and then I going to show you how to fix it.
Yes,
Okay,
thank
I'm
you.
not take you much time to work on just running the lab. Okay, if it pass, it would work. I don't have to show you. I just show you the chart here. Okay,
Thank you.
so good night.
Good night, Mr. Pham. Thank you.
Okay.
that's what you want, Mr. Pham, a lot of D labs, right?
Yes, a lot more D lab is coming.
Okay, so basically, we need to update on up the lab. And you understand the measure on the texture will be the D labs.
D labs.
If you get any problem, you can text to me. I can help you out. If, you know how to do the first one, then later on will be the same thing, only different circuitry. So last time we already learning about the function. Okay, so let me share my screen. Okay, so I not using this one.
Mr. Pham, I think your mic is off.
Can you see? Can you see? Can you see the
Yeah.
display? Okay.
Yeah.
Now, whoever just said something, go ahead.
I was saying your mic was off.
Oh, okay. The thing is, my computer gets something not normal. Okay. So you understand that when you want to write the function, then you have to get the function. Why they said my internet is not working? Can you hear me?
Yes, sir.
Okay.
Yes, we can hear you, but your internet is very low today.
Yeah, somehow, some wrong. I don't know. We try it.
Yes.
Okay. So if you want to write a function, then you have to get the function declaration, right? So that means on the top here. You see that? I get the function, okay, that counting up, for example. Just a minute, okay? Okay, you see the first line, you must get the function declaration. Okay, and from here, going down, there will be a function definition. Okay, and now what I want to tell you, your function definition here, the type of return, void mean you not return anything. Okay, and the next one will be the name for your function. Inside here, we don't have any parameter. Okay, so now when you say for your start counting function definition, okay, anything not inside the loop. You get the loop right here. For j equal 14, j greater than j minus, or whatever. Okay, that's counting down. But one thing make sure I bring it up. Anything, if they not inside the for loop, then you can write down before the loop. The thing is the math data, only one data cannot be changed during for the loop. And you need to write something to put A or whatever. They're not changing during the loop, then you don't put it in. Okay? Inside the loop here, you say they can j equal 14, j greater than 0, j minus. Then now the one will be changing in the loop. The loop will be run 14 times, or 15 times.
Hey, Mr. Pham?
Then the test number will be increment. Okay? That means you will be increment each time j equal 1, 2, 3, 4, 5. Then this will be inside the loop. That's just telling you. If they fail, if j equal 14, then you say peak off will be equal to 4. However, the red peak off will be E4. So that's why they will be inside the loop. And now in here, also they can say if j equal 0, now you want to change the math data depending on your Excel. Then you can say math data equal 1F or peak off different. Then you say U1, U2, U3, U4. And then you apply the clock. And this one will be most of the thing in my program. You cannot change anything in here. Okay? So that is normally for the loop. Anything you not changing during the loop, during the for loop, then they supposed to be outside the for loop. This is for
So
here.
Mr. Pham, the loop is for counting up and counting down only, and then other stuff does not go in there?
Now, what that mean? I say, for example, your math data,
Right.
then do not try to put inside the for loop. Why? This is a for loop here.
Mm-hmm.
Math data is supposed to be up yet before this for loop, the thing is, the math data supposed to be not changing.
Yeah, but the problem is you got that little bracket where you did change the math data to 0xf1f.
Okay, that is only one case. If j equals 0, then you can. That depending on your Excel input C.
Mhm.
Okay, during the loop running for 14 times here, and they want change to the math, that's okay, but you have to using the if statement. If j equals 0 or j equals whatever number, I want to change the peak off, then you can change the peak off. But for the whole thing here, they will be using math data will be 0x. Okay?
Okay.
That's why you want to put it outside. Special thing, you say j equals 0, then I want to change the math. That's okay. but you have to using the if statement.
All right, thank you.
Okay, same thing here. That depending on your Excel. Okay, let's see. I can see.
Mr. Pham,
Yes, sir.
the correct interpretation of the line 127 to 130 that you have in blue is if j equal 14, the pickoff is going to be u1, u4, but for the rest of the j from 13 to 0 is going to be u4, right?
Yet.
Okay.
Exactly.
Thank
That
you.
means that only happen if j equal 14.
Okay, but for the rest, pickoff is going to be equal to u4.
Exactly.
Thank you.
Okay, now, if you're looking into here, they say void. That means no return. Okay? The thing is we have a nothing to return here. So that's why we're using the void. Just display the test they're running, and you don't want anything return. For example, why? Sometimes you're doing calculation something, and they return to your main program. So that's why you need to return. But most of the test program will be void. Okay? And sometimes you can say, how come inside the parameter here, you don't have any parameter? Okay? If you want to get into more detail when few more lab coming, then you see sometimes you will be need to get the parameter here. For now, let it know. Okay, so all of the loop will be almost the same thing. This is the loop depending on they coming from 1 to 16, 15, 1 to 100 or whatever. Okay, then you must be using the loop. So basically, I need to talk to you about the IC data, how they working. Okay. Okay, the first one, you can see this will be 74, 540 or 541. When you're looking into this IC, first thing you recognize how many pieces.
20 pins.
How many pins?
20,
20.
20. Pin 20 will be 5 volt. Pin 10 will be ground. Okay? If I can look into here, input is pin 2, go to pin number 18. Pin 3 go to 17. So basically, this will be a 8-bit buffer. Okay, see that buffer here. Now, buffer, if you want to know how they're working, you can go to the truth table here. Okay, you get E1, E2, E1, E2. Okay, so basically, that will be pin number 1 and pin number 19. Okay, E1, E2 low. Then let's see, if input D equal high, I'm talking about 541. Input out equal high. Okay, but for very simple thing, you get logic 1 in, you get logic 1 out, you get logic 0 in, you get logic 0 out. This is table right here. Okay, now if you get both low and input low, output low, that's a very simple. However, if the input you get a 2 volt, that means logic 1. However, when they go to the output, they try to bring it up to 5 volt as much as they can. Okay, so even they still the logic 1, but the 2 volt logic 1 is not good. They want it to be close to 5 volt. So they can be 3.5, 3 volt, 4 volt, that's good. However, if the enable, you see, high, then the output now will be Z. Z, you're looking here, they say high impedance. Okay, so that means you cannot get right logic. So either E1 or E2 not low, and the output will be high impedance. So that is the thing that you understand that will be helping you to troubleshooting. For example, you measure pin number 2, you get 2 volt, logic 1. And you measure pin number 18, you not get logic 1. Okay? Then what you need to do is you must be check pin number 1 for logic 0 and pin number 19 for logic 0. If you get 1 and 19 0 and logic 1 on pin 2 not go into pin 18, only way you must be changing the IC. The thing is they not working. That's for troubleshooting. Okay? For troubleshooting any circuitry doing the same, you check to make sure you get the right input. However, you not get the right output.
And Mr. Pham, I ask a question on that.
Yeah, go ahead.
I've noticed in the past sometimes, well, when you initially started with digital, you said that a 0 is anything from 0 to 0.8, and I believe it's 0.8, the 2 we don't use, and then either 2 or 2.5 to 5.5 is a logic 1. So a lot of times when you get like either 2 volts or 2.5 volts, and that's like it wants to be a high, but it's not high enough, like a 3. So then the data don't want to go through. What's going on there?
No. The thing is, normally you get the logic 2 volt up to 5, right?
Right.
Logic 1. However, the logic input, normally they get about 2.5. And the output, if they go to the buffer, guarantee they go to higher. That means 3 volt, 3.5, 4 volt. That's why they need the buffer.
Okay. Because sometimes the 2 or the 2.5 is not, I mean, it's technically, it can be a logic 1, but it doesn't really act like a logic 1 because it doesn't really want to let things go through the way it's supposed to.
No, they will. They will be okay. 2.5. That logical one. For sure.
Yeah.
Okay, so this I see very simple thing. Okay. And the
Mr.
next,
Pham,
yeah,
could you explain again what is the NAND gate doing? The previous slide.
what
I
the
think he was
what
talking. I think he was talking about your buffer, the 541. I think he was talking.
Yeah,
about.
the previous slide that Mr. Fan was showing, where you explained that if pin 9 and 18 are
19.
0,
9 and
you please.
1 and 19.
Yeah, that one. So there you have a NAND gate, right, in the between 1 and 19.
That inside.
Okay, and what you said that when 1 and 19 is 0 in each one, you're going to bring the first byte, the first buffer to a high Z.
That means they allow pin 2 go to pin 18. If you make sure pin 1 0, pin 19 0, okay,
Okay.
then they allow you input number 2 will go to output pin number 18.
Okay. Thank you.
Either one at the logic 1, they not allow anything from input here go to the output. Okay, that's what they call enable. Here,
Okay.
enable 1, enable 2. If you're looking in a truth table here,
Okay.
okay, you get 0, 0. Then you get input high, input low, output low. Either one high, they will be high impedance. That's a very simple for the buffer. Okay, input and output will be the same if they enable. Now on this one,
Okay. Thank you.
try to say this one. Also 8-bit buffer 244. And now if you're looking here, you can see pin number 1 enable for 1, 2, 3, 4. Only 4 pin, okay, only 4 pins. And pin number 19 control another 4. So this is a different from the 541. 541, 1 and 19 control 8 pin at the time, but this control only 4. If the pin number 1, 0, they allow pin 2, pin 4, pin 6, pin 8 go into pin 18, 16, 14, and 12. And the pin 19 low, they will be allowed. Input 17 go to 3. Input 15 go to 5. 13 go to 7. 11 go into pin 9. So that is the difference between two IC. One, they control 8 bits at a time. The other, they only control 4 bits at a time. Okay? If you want to control 8 bits, then pin 1 and pin 19 must be on 0. However, sometimes you only want to control 4 bits here for something and another 4 bits here for something else. Then you're able to do it. You can set one to pin 1 to be 0. Then this one will be working. But this one is not.
So
This
which
one-
is better?
Go ahead.
So which is better, the 541 or the 244? Because they're both buffers.
Yeah, they both buffer, but a different way. The other one, you cannot using only 4 bit. You must be using 8 bit at a time.
Yeah, I'm just asking, Mr. Pham, which one is better or?
That depends on application.
Okay, right, got you. Okay, thank you.
Okay, they work in the same thing. Okay, this IC 48, 7448, BCD, binary code, decimal. That means in BCD, you get only number 0 to 9. Okay, and that will be converting BCD to the 7 segment. You can see the segment down here. Okay, if you get the input A1, A2, A3, A4 on 0, then the output, they will be connected to the BCD. They will be display number 0. If you get a number 9, that means input pin 1, A1, 2, 0, 3, 0, A0, 1, 1, 0, 0, 1, that means binary in number 9. Then they will be go into the segment here, they display number 9. That application everywhere, okay, like your watch, digital watch, they display the number using a 7 segment. But inside, they're working with the BCD number. Okay, so when you're doing the lab, this lab will be part of the manual intervention. That means you apply number 9, 1, 0, 0, 1. They're supposed to display segment number 9. But in order to verify it, you must look into the segment. If they display number 9, then you say, okay, good. Otherwise, they will be failed. That means need the manual intervention. So normally you can get a 1 test only for this type of the IC. The thing is, we don't want to using manual. Okay, we want automatic. That means when they run it, fail apart, they let you know right away. And this is just a table telling you which one will be high or which one will be low. Okay, so you can look into here. Okay, like you get input in here. Okay, you can see the output A, B, C, D, E, F, G. A, B, C, D, E, F, G right here. Which one is high or low? Okay. We can try to get the test without the display here. The display here, we must be doing manual. Okay. And I try to see I can get the test for automatic. That means that will be telling you we don't want to go into the segment. Now another one here, 139. They call a decoder, the multiplexer. If you're looking on this IC here, okay, let's see how many pins, 16 pins. Pin number 16 will be power, 8 will be ground. Okay, and now they get to separate circuit inside. Okay. For the first one, enable pin number 1. A1, A, B1. And the output will be 4 output. Now the truth table will be telling you here. Okay. If the enable equal high, okay, that means the Z here, they can be Z1 or Z2. Then what happened? They don't care input A and B. Don't care. Out on the output must be high. Okay. And now if the enable low, then A and B low. The first output Y0 will be low and the red must be high. Okay. And to get another input low high, then the second will be low and the red will be high. That only telling you one thing. Depend on A and B. Okay, I'm talking only one circuit. That will be the same thing. AB0, first low, the red high. And you change AB to 0, 1. That means A1 is 1. B1 is 0. Then the second will be low and the red will be high. So that will be telling you the output only one low at the top. Cannot be too low at the 4 output, only one, depending on input A and B. That's what they call a decoder. That's a very important in any circuitry. Most of the circuitry in digital inside the computer or normally the circuitry digital in the company, they will be using this IC. Okay. And this IC, you can get the truth table here. Okay. If you're looking at truth table, you can see one low, next low, next low, next low, next low. Okay. That means only one output will be low, depending on A input, B input. Okay. And the red output must be high. That is, they call it decoder. So if you want to troubleshooting, then if you get a 0 here and A10, B10, then you know the first output here must be 0. If you measure right here, they're not 0, then your job will be doing a make sure pin number 1 to be 0, pin number 2 to be 0, pin number 3 to be 0, and the output number 4 not 0. I see that's a problem. So that's why if you understand how the IC working, that will be helping you to fix the problem. No more on this part, okay? I get another one. I get another one. Okay, let's see, 139. That we just talking to you, okay? That one is not better to see. You see that the output only 0, 1, 0, 0, 0. That means output only one output to be 0. And the rest of the 4 output, 3 other output must be 1. And that's basically just the truth table. only this only one. That one we already let's see. That one is 164. Okay. 164 here. 8-bit parallel output. Okay, serial input. That means this IC will be converting serial input into the parallel output. Okay, and now you can see for that one, the clear is 0. That means you want to clear the IC, then clear 0. The clock input to this IC don't care. Input A and B don't care, and the output must be low. That's what they want. Okay, and now if you get the clear at the logic high, that means you're not clear. Clock 0, and they don't care A input A input B. That what is the output? Can you tell me? If the clear
Same
at
as
logic
previous.
1 and the clock at the 0, and they said input for this IC don't care. The output will be DA0, QB0. 8-bit, what that mean?
It stays the same.
Right, exactly. You see. That means the output not changing. If the output anything at the output here, maybe they get 1 0 1 0 1 0 1 0. Okay, then you get a high on the clear. You get a low input, then input A and B, no matter what, output still 1 0 1 0 1 0. There will be no change. Okay, when you're reading on the data sheet, if they say A0, B0, Q0, that means whatever it was will be the same. And now you get a high here. Okay, now you get a clock going 0 to 1. And if the input high, then the output will be high. Okay, and they will be shift whatever at the output. So if they give me 0, let's see, in here, P clock, at the first one you clear, you see that output will be 8-bit 0. Okay, now clear at logic 1. You apply the clock going 0 to 1. Okay, A, B1, A1, B1. Okay, then they will be shifted number 1 into QA, least significant bit. Okay, and they will be the significant bit. Then you apply a night clock. What happened? 0 0 here. They will be go into here. Okay, then this number 1 here will be shipped down. Okay, they ship it down, keep shipping down. So if you get a night clock, okay, and you get ABE11 now, so you can see this will be, okay, let's see, they will be go to, that one will be go to the first one, and the next 0 here going down, 1 here going down, 0 here going down. That means they keep shipping up, okay? And this table right here telling you the way they will be shipping up, okay? Anyway, you get the input AB. only serial. Let's see. I try to see here. Okay, these are Excel. Okay, so I cannot draw it.
Hey, Mr.
No.
Pham, can you send that to us via the web if we don't have that already?
You mean I send it to you, that one?
Yeah, that page right there. If you haven't already sent it.
I already uploaded.
Okay, you put it on the web?
Yeah,
Okay, thank you.
that's on the web. You have to
Amy-
upload.
Fam,
Yeah,
this 8-bit parallel out serial shift register in which cases is used? Could you please give an example where this kind of chip could be useful?
okay, just a minute. I can it into my can it to my iPad. Okay,
Okay.
okay, I stop share that. Share my iPad. Okay, let's see more. I see. Okay, now okay, right? Okay, I will make that to you. Let's see, this will be what page right here. Okay. Okay, now we'll see. This is the IC 164. Okay, you get A, you get B, and inside you get the N get T. Okay, I try and make it bigger. Input A, input B. Inside the IC, you can see here. Now, this is the clock, and this will be reset later. Okay, so basically the input A and B, they connect inside for the AND gate. So either way, you want to apply input A. Serial mean 0, 1, 0. Keep going. Okay. 8-bit serial. They will be covered. Go to the 8-bit 1, 2, 3, 4, 5, 6, 7, 8. That means 8-bit output. Okay, so you can be using only one input A or one input B. That means you get only one input. So the way you using A, then output one pin B have to be tied to 5 volt. Why? The thing is inside they get an AND gate. If B 0, then you cannot get anything out. Okay? Either they can using A, but B must be tied to logic 1. Normally, the people doing, I using only one. So I need to connect A to B. That's only one. Because you can see that.
Yep.
And the way when they go, okay, the first bit, I given you a few examples here. Okay, when you apply the clock, clear must be 1. You apply the clock 0 here, go to here. Okay, and the red, you after you clear, output will be 0. Okay, now first clock, this 0 go into first one. And next one, they'll get the next clock, then the 1 will be go to here. However, this number here will be shifted out to be 0 here, 0 here, 0 here, 0 here. Now, next clock for 0 here, then 0 will be go into here. However, you know, next clock is 1 here, okay? You get that, next clock you get a 1 here. So this one go into here. One. Okay, 0. First one you get a 0. A second clock you get a 1. 1 go to the first tab. Okay, and now you right here now. Now you go to the next clock, the 0. So 0 will be go here. But this one will be shifted down. 1. And shifted down again. Everything here. And the next clock you will be get a 1 here. So 1 go to the first one here. And okay, then 0 here, shift it down. 1 here, shift it down. 0 here, down. Okay, so now you go to the next will be 0 here. Okay, so 0 going here. 1 will be shift down here. 1, 0, shift 0, 1, shift 1, and 0. After the 8 bit, if you get a number, okay, 0, 1, 0, 1, 0, 1, 0, 1. That will be 5, 5. Okay, so they will be converting from the serial 0, 1, 0, 1, 0, 1, 0, 1. And finally, the output will be look like. Okay, let's see. 1, 2, 3, 4, 5, 6, 7, 8. So now my question is, when you get the 5, 5, okay, that will be least significant bit. That will be most significant bit. Okay, so if you get a 5 and they will be shipped into this output will be 1 0 1 0 1 0 1 0. Okay, that means 5 or you can get a then 1 0 1 0 1 0 1 0. Then the output will be a 0 1 0 1 0 1 0 1. Okay, so that is how they work it. But you don't have to do anything. We get the program function. If I say you want to send the 5, then you just call the function and put the value 5, they will be send the out for you 5 at it. Or if you want AA, they send AA. You want any data, you can say I want 0 I 5. Then the output will be 0 1 0 1 0 1 0 1. Okay. If you say I want data to be 0 IKA, then they will be 1 0 1 0 1 0. If you say I want 0 I 0 F, that means first one here, 1 here, 1 here, 1 here, that means F, and the rest will be 0. Okay. Did I see they using everywhere, especially in the computer? Okay. The computer, they cannot deal with the serial data. You understand that? Computer only using parallel data. That's why you get a 16-bit computer, okay, 34-bit computer, 64-bit. They're using only the data must be parallel data. However, outside world, data will be serial. Like your void, okay? You can see in the your void, the signal will be analog signal, sideways, okay? When they go into the cell phone, okay, they must be go to the device. What device called? Who knows? That device will be, they call it AD converter. What that mean? They converting from analog to the binary. You see that? Into the binary. And this binary can be go into the computer, they know what's going on. However, when your voice go into outside before they can transmit it, this is the computer here, CPU, okay? When they go into the device, they must be parallel. However, this cannot be using outside. The thing is your voice. So they need to go to another device. They call a D to A converter. So now they're converting back to the sideways. On your cell phone, same thing. Okay? Everything controlled by the CPU. However, input coming in will be serial data. Okay? Output coming out also analog data. Then they need two device, ADDA. Okay? Or normally transfer from the input to the computer. The input normally they try to send in serial. However, the computer cannot do anything with a serial. So they need to divide 164, converting to the binary in parallel, so the computer can do it. Okay? And if the computer done and they want to send it out, but the output device, they cannot get the parallel data. They get serial data. Then they have to convert it back to serial. So you get two IC, 164. That means serial to parallel data. And another IC, 165, parallel to serial. Okay? So any question?
Mr. Pham, in the past, I noticed you mostly use 164. I don't recall you ever using 165.
Yeah, the thing is, we 165 means parallel to serial. Okay? So right now, our computer, our system, will not get that serial. That means cannot verify. So if we want to do it on the system, then I have to convert it back into the parallel. The thing is we're using the text box, they only reading data parallel. And we want it, we have to modify software inside the controller. Okay?
Okay, so you're saying you can't, right now, you only doing 164, but not
Right.
the 165.
Not 165.
Okay, thank you.
If 165, I have to add it into the lab to converting back into the parallel. Okay?
Okay, so you have to change the controller box to use 165.
No, we don't have to stand the control. We have to add in more the circuitry so the control can recognize. Okay? Nothing to do with that. 139 we done. 138.
Hey, Mr. Pham,
Yeah, go ahead.
in the last example, the idea to have the parallel process at the level of the CPU is to speed the process.
You mean
The CPU that you draw there, and all the parallel input outputs from the coming to the CPU, leaving the CPU, is for speed, right? Because if you have more bits, you can run faster a different process.
no, that's not me. I guarantee if you get the more bit in the computer, that run faster for sure. Okay?
Okay.
Before, we get 16 bit at the beginning. Then they go to 32 bit.
Yep.
Then they go to 64. Okay. However, they inside the computer, they only do parallel only. Okay? You send the sideway into it, they not recognize. They only binary. So only in now still be parallel data. So that's why
Okay.
I need to converting divide from the analog signal to the binary.
Okay.
That's what we get AD converter. You will learn next around 2 weeks. Okay?
Okay,
AD
thank you.
converter. Then you have to learn DA converter.
Okay.
In any your cell phone, they must get AD and DA. Otherwise, CPU inside your cell phone cannot recognize your voice.
Yeah, got it.
Okay? Your
Yes.
voice, that means you get a device to get the microphone converting from what?
Analog to digital. Okay, got it. Thank you.
That's good. Now, on this one, 138 also decoder. Last time I showed you 139, that decoder. However, you can see this decoder, they get a enable pin 1 and pin, let's see, EA, EB, enable. That means pin 1 and pin 15. H1 control only 4 bit. Now you get another one. 138. Same thing. Only thing is, if you're looking in here, input, they get 3 input A, B, C. And A, B, C automatically they get the 8 combination right here. 4, 0, 4, 1, 2, 0, 2, 1, 0, 1. Okay, now G to B, pin number 1, 1, 1, and 0. What that mean? Pin 1 will be disabled if you're looking into this one. Okay, G to B, active low. You see the bar over. If they 1, then no matter what or not, the output here will be logic 1. And G to A, active low. Okay, if they add logic 1, all of the output be 1. And the last one will be G1, active high. If they low, all of the output must be 1. That means the IC not working. So in order to apply the input A, B, C to get the output here, then G to B must be 0, to A 0, G1 must be 1. Then now you can see the output, only 1, 0, and the rest must be 1. And then when you change the combination 0, 0, 1, okay, then only one Y1 to be 0 and the rest will be 1. That only telling you, depend on the combination here, only output at a 0, okay, and the rest must be 1. So that is the same thing decoder on this one. On this one, only 4 bit, okay? Only 1, 0, the rest have to be 1. But this one they doing for 8 bit. The thing is when you understand how they working, when you're doing the lab for the Excel, you understand how to apply the right input, then you can get it passed. Okay? If you don't understand how the IC working, then you cannot make it pass. Okay? And that's also the truth table. Okay? And I already upload both the IC data. Okay? You can download it. When you get the lab related into what I see, you can see it. Normally, you can go to the Google. You can type in 74138. They will be show you everything we're telling you today. Okay? If you get the knowledge how to reading the data, then you're able to read on the Google. Okay? Any question? Otherwise, I can get one more thing here quickly. Octal means là 8-bit. Latch. You understand latch? We only get the D latch. 373 D latch. That means the difference between the 74, okay, 173 or something, but the difference between the 373 that deluxe, the thing is, they get 8 input and they get 8 output. That's it. Only thing is, if you're looking on the input pin number 1, how much you understand? Pin number 1,
Output enable.
output enable. If they be 0, okay, output will be enable. If they are logic 1 on pin 1, output disable. Okay, and let's say LE, looking LE right here. Now, if I say input at the logic high, out LE at the logic high, okay, output enable 0, then the output will be high. That will be telling you one thing. If you get a 0 here, okay, and the input D0, 1, 2, 3, 4, 5, 6, if you get a 1, 0, 0, 0, 1, 0, 0, 0. Now, output on the other side, okay, LE at the logic 1. Then 0 here go to here. They go to the output, okay? Whatever you get in, they go to the out. That will be one, okay? Now, that's just telling you, if you get the input 1, 0, 0, whatever data, okay? This 0, that 1, then Q0 equal D0. Whatever in here will be go into the output. Okay. Now, next, if you get a 1, at the output enable, what happened? If you want to know, you look into here. 1. Then the output will be high impedance. That means not logic at all. If the output enable equal 1, okay, and the output will be high impedance. That is what they call an output control. Now, if you get input here 1, 1, 1, 1, 1, 1, 1, 1, and LE equal 0, what happened?
Stays the same.
That means the output, you are looking in here, LE 0 here. No matter what the input, the output will be low Q0. Okay, that means if you get a 0 here, output cannot be changed. You get either you change the input here, but the output still the same, cannot be changed. Okay, now I get another question here. Okay, if you get,
Sorry, Mr. Fan. Got a question for you. When you say high impedance, okay, so when you have high on OE, output enable,
uh-huh,
and you got the input of 1, 1, 1, 1,
uh-huh,
and the LE, low enable, is doesn't matter what it is. It say the output would be high impedance. So
Right.
what is the output then?
That can be any.
So it doesn't mean anything whatever the output is.
Right.
So if you put a meter to it, it doesn't
You can
matter.
measure, you can get 1 volt, you can get 3 volt. That means they not any logic.
Okay.
Okay.
Right. Yeah. All right. Thank you.
That is a output impedance. But the thing is, when you can answer my question here, then that means you understand how they working. I given you input 1 here. Okay. Now, if I set this to be 1, this still be 1, then what happened?
High impedance.
No, high impedance. However, you get this to be a 1. Okay. LE to be high. Okay. I telling you. What happened is the data here will be shipped into here, inside. Okay. They already inside the IC. But they not go into the output. The thing is, this still be logic 1. Now, if you change that to be 0, so output will be go 1, 1, 1, 1, 1, 1. Okay? That means when you get a logic 1 at the LE, data will be loading from input, go to inside of the IC. They're not going outside yet until output enable to be 0. The thing is, you can see they're using a lot of time for this IC. How come? The thing is, they will be 8-bit. If the computer 16-bit, they're using 2 IC. If the computer 32-bit, then they're adding more IC, depending on how many bits of the computer. Okay? So I think we can stop now for today. Anyone get a problem with the D-Lab, try to contact me. I will help you out. In this program, if you cannot doing any D-Lab, what can I help you? Okay? Any question?
Thank you, Mr. Pham.
Yeah.
Thank you, Mr. Pham. See you
Thank you, Mr.
tomorrow.
Fan.
Yeah, no problem. I really happy if more lab student uploaded. Okay.
Okay,
So,
okay, everybody, make sure you upload D-Lab number 99.
okay, so good night, everyone.
Good night.
Thank you.
Good night.